Hello everybody. I'm going to present my master's thesis with Texila American, Harmonization of Thyroid Stimulating Hormone, an Alternative Approach. At the Nairobi Hospital, the lab receives about 15,000 tests a year for TSH, Thyroid Stimulating Hormone, and we get a variety of patients who are normal, some are abnormal. The majority are usually normal, but for those who are on the borderline of TSH, which is about 5 or above, just above 5, we are having a little trouble with how different machines are measuring. So in a lab that has more than one machine, a decision now has to be made on how the TSH will run. So right now, currently, the TSH is run on a Roche Cobas or Abbott Architect I2000. They're similar methods, slightly different. The decision to run a patient sample for TSH on either platform is random. Both Cobas and Architect have a quality assurance program. Daily internal quality control samples are run, and external quality assessment is done, which is quite successful, and each machine is showing very good trends. But a dilemma is met when subclinical high or low TSH values are encountered. So we have to confirm. So the patient's value that's run on one machine has to go and be run on the other machine. And then we are in trouble, or we are troubled when one machine is reflecting what looks like a normal value according to the range for the patient, and the other machine is saying no, this value is high. Now labs usually select their machines primarily to perform thyroid testing on the basis of instrument menu, operating costs, because it just doesn't buy a machine because of one test, several tests. Usually the menus are long, and the more technology advances, the menus become bigger. Also their operating costs, supply, availability of reagents, something like that. So it only secondarily recognizes that there are differences in the functional performance of different methods. So the general objective of this study was to harmonize TSH test between these two analyzers or platforms for better management of the patients, because thyroids are very sensitive. The specific objective would be to compare data from the two analyzers and to recommend for the lab a course of action for better management of thyroid disorders. In a study on an Indian urban subpopulation carried out by Sarkar, it was found that a systematic difference existed between the two methods. The study also suggested that the instrument factor, if the instrument factor of Cobas, which is normally 1, is put to 0.783, the TSH value would be correspondingly lower and would match those of Architect. Conversely, if the instrument factor of Architect is changed to 1.277, its TSH values would match with those of Cobas. The main drawback of this method is that it assumes that one of the two instruments is generating correct values and the other is not. I must bring to your attention that TSH, contrary to other analytes or lab tests that have standards, it has no accredited standard. So we cannot also talk of a method that is a gold standard. And that's why we are harmonizing TSH, not standardizing it. You can only standardize if you have a standard calibrator or a reference standard method. In a different study, data sets obtained from 4 different immunoassay analyzers, poor and statistically different correlation was observed between analyzers at TSH values ranging from 1 to 10, compared with FT4. The study concluded that these variations between analyzers may affect the clinical decisions, especially in the evaluation of subclinical hypothyroidism. Clinicians and laboratory specialists should be aware of these situations, which we are trying to do in this case. The method used was analysis of retrospective data. Sarkar used patient results, and patients come in all sort of situations. Some are sick, Some you would test the thyroid, but to check on another aspect of the patient or another disease. So I decided let's check for quality control data first and see purely just the comparability of the two methods without including patient situations which vary in health and in disease. So IQC material used is Randox Premium Immunoassay. I used two different levels, a level 2 which is round about normal, meaning that it's about where the normal range for the patients exists, and level 3 which is a high level. 590 data sets were obtained for daily internal quality control runs between January 2015 and June 2016. The data analysis was carried out using R project version 3.2.3. First, a test was done to calculate if a difference exists between the two analyses and whether this difference is significant. That was the Shapiro-Wilk test. The distribution pattern of the data was calculated to guide choice of regression method that would be appropriate for method comparison, which is paired t-test and Mann-Whitney-U-Wilcoxon. You will see later in the diagrams that the level 2 data showed normal distribution, so the paired t-test could be performed there. Level 3 data showed not normal distribution, so Mann-Whitney-U-Wilcoxon test was used there for regression, for choice of regression method according to the distribution. To compare the two levels, which means one showed normal distribution, the other didn't, regression methods like Deming and passing back block were used. Passing back block because it does not take into consideration any special considerations for the data, so we are able to use both normal distributed and abnormal distributed data. Concordance correlation coefficient was obtained using the Lawrence-Lin method, and Bland-Altman plots were generated. The following slides will now show results obtained for each level 2 and 3, and in some cases the combined data. This is a summary of the initial statistical analysis. You can see there the I don't know if you, let me use the pointer. This is Shapiro-Wilk test for distribution. So level 2 here, from the result, p-value 0.5, that's a normal distribution. Level 3, p is less than 0.005, which is not normal. The combined data, which is level 2 plus level 3, all the 590 data sets, showed not normal distribution. Okay, we will go to the next. Yeah, regression analysis findings now. Deming would take measurement errors into consideration, so we were able to do Deming regression for both levels, and passing back block, which had no special consideration for the data. But you see, it produced for level 2 intercepts that were almost similar, and level 3 Deming and passing back block also had intercepts at 95% confidence interval, and the slope at level 2 for level 2 by Deming regression and passing back block are almost similar, almost 1. Same case for level 3, and also the combined data. Pearson's correlation showed a poor correlation for level 2 data and level 3, and quite a strong correlation for the combined data. But our main interest is for patient levels that lie around where the level 2 data comes, where we have the subclinical thyroid patients. Concordance correlation shows a poor correlation between the two. The bias correction factor down here, 0.1, 0.6 and 0.98 for the combined data. The bias correction factor measures how far the best fit line deviates from a line at 45 degrees. No deviation from the 45 degrees line occurs when the bias correction factor is equal to 1. In this case, none of them were equal to 1. And level 1 and level 2 and 3 individually showed quite a poor correlation. This is the bland. This is passing bar block for level 2. As you can see, this would be the line of equality right here in the middle, but all the data was concentrated somewhere above that line. This shows that for level 2, 3 and the combined data, this just reflects that COBAS values were on the higher side in all cases than the architect values. This is for paired data, which means the same sample run on COBAS and architect, the COBAS value would always give a slightly higher value than the architect result. The bland Altman plots would reflect the same thing, that there is a difference between the two machines, because the difference between the two for level 2 plotted against the mean, and for level 3 there's clustering of all the data values away from 0, whereby 0 would mean no difference, but in this case all the data values are clustered away from 0, below 0. So the architect value minus the COBAS value would give you a minus, as a negative result, because the COBAS values in all cases were higher than the architect results. So the data clearly demonstrates that there is a constant systematic error between the two methods, with COBAS values reading higher each time, and that this difference is significant at both levels 2 and 3. The constant error is demonstrated by the intercepts obtained by the regression analysis by the two methods, returning values that differ slightly due to the difference in the calculation formula of each of these two methods, and considerations taken into account for each method. But it showed positivity toward COBAS values. That means the COBAS values in each case were higher. Concordance correlation of the individual levels 2 and 3 is poor. Even though the combined data gives a strong correlation, this is not of clinical significance, since the range under consideration in the subclinical level of TSH, where symptoms are not yet apparent in the patient. That is where the importance of the lab test comes in, whereby
Ms. Izza.
can help diagnose a condition.
Hello, Ms. Izza, you got another 2 more minutes.
Appear on the patient.
Hello.
Yes? Yes.
Okay, you got another 2 more minutes.
Okay. Almost done. The conclusion is the results obtained infer that much as the regression analysis shows transferability of one method to another, the difference in means and the poor concordance correlation obliges a consideration of the TSH result released by the lab and its impact on patient management of thyroid disorders, especially those in the subclinical range. In its current test, it would be prudent to report TSH tests individually, citing in each instance which machine was used, so that the clinician can make a better decision. The factor calculated by Sarkar was not very well applicable to both levels. It means that if one factor is used for each level, then we might have a problem converting accurately. These are the references that were referred to. Thank you very much for listening in, and thank you Texila for the opportunity and the e-conference organizers. Thank you very much.